Welcome to question 8 in the homework 10 series. So for this one, we are going to determine which of these statements about sulfur dioxide are true. So our game plan is that just like homework question 10.7, we're going to draw out Lewis structure and we're going to answer them questions. So we're going to jump straight into the meat of it. We'll get to our Lewis structures here. So we have these 3 possible Lewis structures for SO2. So for the first one, says that the central sulfur atom is sp2 hybridized. If you look at all of our Lewis structures, if we're sp2 hybridized, that means we're looking for 3 electron groups around this central atom. We've got 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is going to be an sp2 hybrid in all these cases. So this first one is going to be a true statement, right? Our second statement says that there are 2 sigma bonds in SO2. So remember, a single bond contains 1 sigma bond, a double bond contains a sigma and a pi. So in this case, we're going to have 1 sigma, 2 sigma, 1 sigma, 2 sigma, 1 sigma, 2 sigma. So each of these structures contains 2 sigma bonds. This is also going to be a true statement. Statement 3 says that there are no resonance structures for SO2. This is false. We have these possible other resonance structures over here that are legitimate, they are valid. Nothing is wrong with these guys. They're okay to use them. So I think it's kind of hard to see these other 2 resonance structures. So if you came up with this one and then you didn't realize that these were other resonance structures that were possible as well, that's okay. What I'll say for that, just try to think about where your electrons can go. Basically what we have happening is that we're just able to delocalize these double bond electrons and move them throughout our structure. All right. So then our fourth statement says that one of the sulfur oxygen bonds is longer than the other. This again goes back to the observed structure that we talked about with the carbonate example. If you go to video 7 of this homework 10 series, you can see the observed structure for carbonate. It's going to be the same thing for SO2, where when we're looking at the real structure that we would see in nature for this compound, sulfur dioxide, we'd be looking at an average of these 3. And the average of these 3 structures is going to be something like this, where we have both those double bonds. They're not going to be, each one isn't going to quite be a single bond. It'll be something a little bit more than that. So both of those sulfur oxygen bonds are going to be equivalent in length, all right? And then the last one, so this got a lot of people on exam 3, talking about the bond angle for SO2 sulfur dioxide. Okay, so technically, there's been a lot of debate about this, and I personally don't agree with the way that this is all heading, because now this question is confirming the fact that the bond angle for sulfur dioxide is about 120. So because it says about 120 and not exactly 120, like on the exam, this is a true statement. That's really nitpicky, though. I'm sorry. I sincerely apologize that happened to you guys on the exam. But what's actually going to happen is, because of this lone pair, we're going to get some increased repulsion from it. It's going to push these 2 groups a little bit closer together. Instead of having exactly 120-degree angle, it's going to be approximately 119 degrees. So that's the real bond angle of SO2, and that's why that question was false on the exam. It was literally 1 degree off, so I apologize for that. But these are going to be the answers for homework 10.8, and that'll do it for this video.